Good morning and welcome. I'm Steve Schloemer, and I will be your presenter today. I've been working on all types of blending equipment and blending applications for the last 32 years, including R&D development, manufacturing, test labs, and sales. Today I'm going to talk about the differences between a double ribbon blender and a fluidizing paddle blender and why you choose one over the other. This webinar will be posted on YouTube in the coming days. We will also have a Q&A session at the end of my presentation. You can ask a question at any time using the chat box, and we'll address those at the end of the presentation. I ask if you keep your questions general. If you have any specific questions, you can contact me directly. My contact information is currently on the screen, and we'll show it again at the end on the last slide. We'll start off with the basics, then we'll review the design of each blender. The ribbon blender has been the workhorse and the most common blender for the last 150 years or so. Let's just talk about a little bit about the basics design of the ribbon blender. The double ribbon blender has two horizontal helical ribbon tools. There's an outer tool and an inner tool. The outer tool, it holds a pretty tight tolerance to the vessel wall. It is used to push material from the end plates to the center of the mixer. And then the double ribbon, so there's an inner ribbon as well. This inner ribbon is designed to push material towards the end plate or away from the center of the unit. The outer ribbon, obviously with a larger diameter, has a higher pumping capacity than that of the inner ribbon. It is not uncommon to see material higher in the level higher in the center of the mixer than the outside, just because of the higher pumping capacity of the outer ribbon. It is recommended with a ribbon blender because of that same feature to charge it in the center of the mixer, not on the either ends. This way you get a little more efficient blending with the material starting in the center and the pumping capacity of the outer ribbon. For efficient blending, you really need to have about a 60% fill level. You want to have the material high enough in the unit so that the inner ribbon is actually effective in not only seeing the outer ribbon, but seeing the inner ribbon as well. So typically a ribbon blender has a filling capacity of 60 to 100% of the stated working volume. Typical blending time for a double ribbon blender is 5 to 6 minutes. Before I talk about the fluidizing paddle blender, which we're doing the comparison with today, I wanted to talk about the traditional paddle blender that you may have seen or used or heard about. The traditional paddle blender has just a single outer type of paddles and has a similar RPM, shaft RPM, as that of a double ribbon blender. So just wanted to make sure everybody understands when we're talking about a fluidizing paddle blender, we're really not talking about the more traditional paddle blender. We're talking about today about the fluidizing paddle blender. Excuse me. The fluidizing paddle blender is relatively new to the market compared to the ribbon blenders. It's been around 10 plus years or so. It was really designed to overcome some of the shortfalls of the double ribbon blender and improve blend quality with a shorter mix time. So we're going to kind of talk about those features in a moment here. But when I use the word fluidizing, I'm not talking about an air fluidizing method, but I'm talking about a mechanical fluidization of the material. So the fluidizing paddle blender, similar to the double ribbon blender, has outer paddles that meet up with the wall. And then there's also shorter paddles that only go about 2/3 of the way to the wall. So we have, similar to a double ribbon blender, you have an inner and outer set of mixing tools. The fluidizing paddle blender typically operates about 1.5 times of shaft RPM of the double ribbon blender, so it is a faster RPM than you'll see. So that combination of shaft speed and the inner and outer paddles results in a mechanically fluidized bed of material. This mechanical fluidization of the material allows a greater variance in the blender fill level. The fluidizing paddle blender can be efficiently blend materials as low as 25% of the working capacity. So compared to a ribbon at 60, we can go from 25 to 100% fill level with the fluidizing paddle blender due to the increased shaft RPM that we see with the fluidizing paddle blender. So a typical blending time for a fluidizing paddle blender is about 2 minutes compared to a ribbon blender that's in the 5 to 6 minute range. So that is the basic difference between a double ribbon blender and a fluidizing paddle blender in terms of mechanical construction. I want to spend a few minutes discussing a few material characteristics that come into play during a blender selection. So one of the big ones that we see in the market is that if there is a particle size variation or even a material density variation, these variations can lead to product segregation during blending and post-blending. In general, the larger the differences in particle sizes or density, the harder it is to blend and maintain homogeneity. So the ribbon blender, larger the differences in particle size and densities, the longer the ribbon blender will take to achieve that. In some situations, when you get into very large variations, the double ribbon blender can overmix and the product can begin to desegregate during blending. So you can actually see if you pull samples, if you pull a sample at say 2 minutes and then later at 3 minutes, 2-minute sample may say, yeah, I got a good blend, and at 3 minutes, it may not be a good blend just because of the way the material behaves and the low mix action that you get out of a ribbon blender. The mechanical fluidization that we get with the fluidizing paddle blender helps to create space between the particles and allows them to move past one another. This mechanical fluidization allows the blender to efficiently achieve homogeneity with particle size and or density variation. So that mechanical fluidization really allows a freer moving material in there and can overcome those variations. I do want to mention that you can, once you achieve a good blend with either blender, that you have to take good care of the material as it is discharged and handled after the blender. You can see segregation after the blender if the blender is not properly vented, or the material has a far drop from the mixer to your receiving container. So just a word of caution there, that you want to make sure that you're handling the material properly after it comes out of either of the blenders. So one of the properties we want to talk about a little bit is the angle of repose. The angle of repose of a granular material is the steepest angle of descent to the horizontal plane to which a material can be mounted. So basically, if you take material and pour it out on a table, the higher it mounds up, the higher the angle of repose. The higher the angle of repose, the more difficult it is to blend materials. It just gives your raw materials have a poor flow characteristic, if you would, if you have a high angle of repose. And that's what we're really talking about here with this material attribute, is flowability. So higher the angle of repose, the harder it is to blend. Some common causes of that, if you have very small particles. Those particles can tend to bond together through ionic or van der Waals forces. If you have a crystalline material where it's cube shaped or highly irregular shaped particles, those will all contribute to high angle repose. So if your materials have a high angle repose, double ribbon blender will generally require some additional blending time compared to a low angle repose. And again, with that poor flow characteristics, any kind of minor ingredients within the ribbon blender, you would want to charge towards the center of the blender versus the outer end plates. With the fluidizing paddle blender, that mechanical fluidization that in the space we're creating between the particles gives them more room to move one past one another and with less friction and less interference with each other. So generally, the fluidizing paddle blender generally don't need a lot of additional mixing time, may require some, but generally it is less of an impact with the fluidizing paddle blender because of the mechanical fluidization that we're achieving. So in general, the higher the angle of repose, a little longer it's going to take you to blend it, and will require higher horsepower generally for either of those type of blenders. So just something to take consideration when you're doing your selection. Just want to briefly mention shear forces. When I talk about shear, I'm talking about, I'll give you the definition here. Shear occurs when two forces act upon each other in different directions. For example, when you rub your hands together, the shear is the friction between your hands. So generally, either of these blenders are going to generate shear when the mixing tool forces the product between the leading edges of the tool and the vessel wall. So the more impact you have at the wall, the more shear that you're generating. You can also incorporate shear into a blender if you needed additional shear for either style blenders with choppers. And choppers can have different type of tool heads on that depending on the amount of shear that you want to add. So there are lower shearing and higher shearing type of tools, just something to keep in the back of your mind if your product you believe needs shear in it. So I wanted to talk about shear because that brings up my next point in terms of product friability. Friability is the tendency of a particle to break into smaller pieces under duress. So the higher shear that your mixer imparts on your product, the more likely you're going to see attrition of your product in there. Now that's not always an issue, but that is, for most parts, contributing decision making on a blender selection of whether or not you're creating attrition or not. Some applications do require shear, and we'll talk about that in a little bit. But generally, a double ribbon blender will impart more shear to a product than a fluidizing paddle blender. An example where, say, in a product where shear is beneficial would be something like a powdered drink mix, where you're adding a flavoring in or a coloring, and you want to get a good distribution of that onto the sugar. Sometimes a little extra shear helps that and gives you a good dispersion. The fluidizing panel blender, again, that mechanical fluidization, you're going to hear me talk about that a lot. We create the space between the particles and we allow them to move past one another with little to no attrition to those particles. So very effective with like whey protein products, whole coffee beans, whether they're green or roasted, and nut-based trail mixes. The fluidizing paddle blender is not a zero shear blender and will impart attrition to highly friable products. So if you have a product such as a parsley flake and or a freeze-dried fruit, you really need zero shear. And when you start looking at those type of raw materials, then you start looking at material addition and how you add them to the blender and when you add them to the blender. Liquid addition, if you're adding liquids, it can certainly be a factor in blender selection. And things you have to look at is how much liquid are you adding? How fast do you need to add it? Viscosity of the liquid. In general, the higher the percentage of liquid, the less critical the application method. It's not always true, but just in general. Additions of liquid additions that are high viscosity, or say less than 1% of the batch, might require management of the droplet size that you're spraying. So you can get into more technical areas of spray nozzles depending on the type of issue, the type of liquid that you're trying to add. So in general, you know, the ribbon blender is slow to bring new material to the surface because of the slow RPM. And if you're adding liquids in a ribbon blender, it generally requires a little longer mix time. And you have to add your liquids a little slower so you're not creating agglomerates of the material to make sure you get good dispersion. So the good thing about the ribbon blender is that if you do create some agglomerates, you do have some extra shear going on with the ribbons on the walls that you can possibly break up those agglomerates. That is a nice addition of the shear that the ribbon blender brings to that. But again, we talk about that mechanical fluidization of the fluidizing paddle blender. We're bringing material to the top surface on a more frequent basis with the higher shaft RPM, as well as, we talk about that mechanical fluidization where we're creating airspace around the particles, if you would, that allows you to get a better coating onto your raw materials as you're adding the liquids. So that it can be an advantage with liquid addition with the mechanical fluidization of the fluidizing paddle blender. Just in general, we talked about the Frood or the Froud number, depending on how people pronunciate it. But generally, horizontal guys such as us that we're producing ribbon blenders, fluidizing paddle blenders, we use the Frood number in scale-up calculations, and it is the ratio. It's a dimensionless number. It's the ratio of centrifugal forces versus gravitational forces. So again, it's mainly used for scale-up calculations, but it is an interesting number to look at when you're comparing the two mixing styles. So the double ribbon blenders are generally built in that 0.5 to 1.0 Frood number. The fluidizing paddle blender is typically 2 to 2.5. So you can see we have higher mechanical lift to overcome the gravity with the fluidizing paddle blender. So typically higher the shaft RPM, higher the Frood number, but you know, mixing takes place in the voided area on the backside of the mixing tool. So as that tool comes through the material, it creates a void on the backside. As material flows around the tool, that's where your mixing's taking place as that material fills that void. So, you know, we talk about the Frood number and we can talk about shaft rotation, but obviously the mixing tool obviously plays a significant role in the blend and the blend cycle and the blend quality. So, you know, again, the Frood number, you might hear people talk about that. It's really used to talk about scale up, not necessarily to describe the blend quality that you're achieving. All right, so kind of went through material characteristics that you have to take into consideration when you are selecting a blender. And just a quick summary of that as we go through. We look at batch size flexibility between the two. Again, the fluidizing paddle blender has a larger variation with the blender design. Again, blending time, generally the fluidizing paddle blender is quicker. May not be necessarily true if you have to do liquid addition and you have to control that weight rate of liquid addition. The advantages of the fluidizing paddle blender may be diminished a little bit there if you have to control your liquid rate. But in general, the fluidizing paddle blender is a faster mix time. If you have blends that have size variation, the fluidizing paddle blender is a better selection. If you have variation in density, fluidizing paddle blender is a better choice. High angle repose, again, the fluidizing paddle blender is a better choice. Now, if you have agglomerates or if you need some extra shear, a double ribbon blender could be a better selection for you. If you have a fluidizing paddle blender, we can certainly add choppers to it to give you that shear. It is an added dimension, an added motor, an added maintenance item, but it can be done in a fluidizing paddle blender. But that is where the ribbon blender excels on the fluidizing paddle blender, is if you have that shear and you have friable products and you want that attrition. So, but if you don't want that friability, you don't want the shear, the fluidizing paddle blender is a better choice. And in general, liquid addition is more efficient, and we see better coverage with the fluidizing paddle blender. So I just wanted to take a quick few looks at some applications that we may run into. Some common ones that we run into is a biscuit mix. Typically with a biscuit mix, you do not want an even dispersion of the shortening or the fat. It is not desirable to have that distribution. Or I'm sorry, yes, that's correct. You do not want the distribution because you want fat agglomerates in there. So in that sense, the ribbon blender has been the workhorse in that arena, but really at the end of the day, because the fluidizing paddle blender does not have that shear and doesn't shear all the shortening or the fat into the mix, the fluidizing paddle blender is really the better choice, even though the double ribbon blender has been the blender of choice out there. So something to think about. Both can certainly work for you, but in that situation, the fluidizing paddle blender would be the better choice. A breading mix. Breading mix, it typically has flour in it, has a higher angle repose, so it's does not have great flow capabilities. You're going to have salt and sugar, so now you have particle size and density variations in your blend. So in this type of application, we would recommend the fluidizing paddle blender. The mechanical fluidization with the high angle repose of the flour, the bulk density and particle sizes that you're getting with the salt and sugar and other minor ingredients, we would recommend a fluidizing paddle blender over a ribbon blender. Coffee beans. So obviously a lot of roasters and blenders want their beans to remain whole. They don't want them broken into half. So green whole coffee beans are a little less shear sensitive than a roasted, but again, we don't want a lot of shear. We don't want a lot of breakage. So the mechanical fluidization of the fluidizing paddle blender again allows us to have lower attrition with this type of application than a ribbon blender. It's interesting and I may mention this again later with with the trail mix, is that if you run the fluidizing paddle blender at slower speeds, say the same shaft RPM as the ribbon blender, we actually see higher breakage of beans and trail mixes with a slower speed with the fluidizing paddle blender. So it shows even though you think about a higher shaft RPM and more aggressive mix would be detrimental, actually just the opposite is true. So just an interesting little fact there. Flavored drink mixes. We talked about this a little earlier. If you're adding a flavoring or a coloring and you're adding that onto a sugar base, shear is your friend there to make sure you get even distribution of that. This is one of the applications where the double ribbon blender is probably a better choice for you because of that shear. Fluidizing paddle blender, you can add a chopper to that. You do have to be cautious with using a chopper because the chopper can be very aggressive and can result in some attrition of your sugars if you're trying to maintain a certain sugar profile or particle size there. But this is one of the areas where a double ribbon blender is probably a better selection than the fluidizing paddle blender. Kind of the opposite of the biscuit mix is the pancake mix. Again, you have fat in there, and with the pancake mix, you want very even distribution of the fat, and you want some shear. So again, with this, and I have to apologize, but with the pancake mix, the double ribbon blender is another good selection for you there because you do want a good distribution of that. So I should have a ribbon blender listed there with that. I apologize for that, but the shear, with the pancake mix, you want a good distribution of that fat, and again, the shear that the ribbon blender provides is able to get a good blend of the fat with your materials. It doesn't mean you can't use a fluidizing paddle blender with a chopper to get there, but that is another area where a ribbon blender might excel for you. All right, let's get to the seasoning and spice blend. This is really one of the applications where a fluidizing paddle blender can excel for you. Seasoning blends tend to have high particle size variation, high density size variations, as well as shear sensitive ingredients such as a parsley flake. So with the fluidizing mix action that you would get and the lower shear, typically a fluidizing paddle blender is our recommended choice there for seasoning and spice blends. Seasoning and spice blends a lot of time will have an added liquid to that, such as an oleo resin or something like that. When you're doing that, it becomes very critical that you have a correct liquid addition system set up for liquid addition for viscous materials such as an oleo resin. Trail mixes, fluidizing paddle blender would be our recommendation there. You have nuts such as cashew or peanuts. Most blenders want to keep those as whole cashews or whole peanuts. They don't want damage done to their chocolate coated candies. They don't want damage done to the raisins or cranberries that are in there. So again, a lower shear mixer is certainly recommended here. with the fluidizing paddle blender for those type of applications. So, you know, every product blend is unique, can have nuances to it. Lab trials are always encouraged when practical. Most vendors have units that can be utilized to confirm your blender selection. So I highly encourage you to take your application and run a trial with it to make sure you're getting the blend that you want to do. You know, we hear us with American Process, Eirich machines, just a little plug here. We are doing virtual tests at our test facility with the pandemic, so people don't necessarily have to travel. We have cameras set up to be able to view and watch the trials, and we put you right in, you know, in contact with the lab people going on and doing trials, so you can be in constant contact with them. Highly recommend doing trials with a product for your selection. So I thank everybody for their time today. If you have any questions, please go ahead and enter those into the chat box at this time, and we'll see if we can't get those answered for you. Again, my email address is up there. If you have any specific questions down the road, feel free to reach out to me or give me a call, and I'd be happy to answer any questions for you. So, do we have any questions today at all?
Hello, everyone. This is Lena Edstrom. I'm the marketing manager with Eirich Machines. Steve, no, it looks like we don't have any questions for now.
All right, so, excellent. Please, if anything comes up in the coming days, feel free to reach out to me. So again, thank you for attending today, and I appreciate your guys' attendance, and have a great day.